Oh, what the fuck? Live chat is unavailable. My Streamlabs so ass. There you go. Now I have chat. Okay, this one doesn't look too bad. Oh, whoops. I guess comma space. Oh, strings. Oh, so it's already perfect. Oh, why did I call it output? Okay, we got all our towels. Next is to import all our patterns. Um, oh. Uh-oh. I forgot. Oh wait, I could put it here. And then I can save a line here. Yeah. Oh. Huh? Why can't I strip it? Oh. There we go. Oh man. Why did I get the last one? Oh, the previous way was better. Yeah. Shit, Edwin is watching. Edwin in the chat. He doesn't understand anything, but he's watching. Wait, how do you know I'm streaming? This is how you subscribed. Guess how do I DFS this? Oh, you want the current index, so just current. Oh, and the string that we're at. Oh, whoops. Yeah. For towel and towels, if a pattern from current to the length of the towel is equals to the towel, oh, so it should never go over. You understand it now? That's crazy. Then you DFS from current plus the length of the towel, and it's the same pattern. And then you want to know if one of them is found, so Okay. So now I got the DFS. Part 2 star you get to get for having all the other. Wait, what? Okay. So got the answer equals 0, and then for patterns, if DFS at 0 and of the pattern, then answer equals 1, and then print the answer. So then I think this should work. Boom, 0. It doesn't work. Okay. Okay. Why does it give up right away? Zero is inclusive, yeah. Length of the towel, that should be fine. And wait. I got the towel. Oh, whoops, it's pattern. Oh my god, I'm fucking myself up with singular and plural. Maybe I should call it P instead. Boom. Still 0. Okay. Oh, what the fuck? Why am I having spaces? Okay. Okay, my pattern's fine. My towels look fine. Okay, so let's print current and P. Yeah, let's just do the first one. Wait, what's going on in this print? What the fuck? Oh! Current plus length of towel. There we go. And then now this should work. 6, there we go. Now I get the puzzle input. $228. Okay, part 2. The staff don't really like some of the towel arrangement you came up with to avoid an endless cycle of towel rearrangement. Maybe you should just give them every possible option. Here are all the different ways to make the above examples design can be made. Okay. So you got all these ways, and then adding up all the ways the towels in this example could be arranged yields a 16. They'll let you into the onsen. Okay, so you just want to add up all the possible ways. So then this is DFS1, I guess. And then, so that's part 1. I'll just call it DFS and put all of this in part 1. Okay, and then part 2. It's the same thing, but a bit different. But now I don't know if I'll run out of time. So this should be equals to 1 when we reach the end. And then found is going to be equal to 0. And then we do found plus or equals DFS or whatever. Yeah. And then we just printed the DFS. So I'm guessing this is gonna wait, oh no, you gotta add them all up. So yeah, just add up the DFSs, print the answer. I think this should work, but it might be too slow for a giant input. Oh, okay, I'm struggling. Oh, okay, that's the giant input right now. Is it cooking? Wait, let's print. Okay, let's I and pattern and enumerate patterns, and then print I answer. Okay, let's see how it is. Okay. Yikes. It's cooking for a while. That's not good. Let's test it with the smaller input first. See if at least I wrote it correctly. Okay, 16. So now I think the problem is just it's too slow. So I need to figure out a way to make this fast. I think what you want is seeing if like any towel is a substring of another towel. No, if you want to see if you're able to combine towels together to make into another towel. It's a bucket. Oh, there it is. Dark mode paint. So here it says let's say RRBGBR. So yeah, RRBGBR can be made 6 ways. So we got too lazy to type them all out. Yeah, so these two can be combined into this one. Yeah, so it creates new possibilities when you're able to combine them to make new ones. So how do I save time counting using that knowledge? I guess you could have like building blocks. And then let's say you have R and B. You have R and B separately, can be formed to make RB. Wait, oh, you want to see how many ways there is to form RB? So RB, you can form it with RB or RB alone. There's 2 ways. GB can be made G and B or GB. So when counting, but there's some times I'd want to use G alone. But how can I save checking G and B separately when I know there's GB already? Should I be checking the biggest first? Yeah, I think I should be checking the biggest first. And then fuck. Let's say we had like A, B, C, C, D, I don't know, something like that. And then you have A, B, C, D, and you have B, C, D, and you have A, B, D, I don't know, something like that. We check the bigger ones first. So let's see, try this one, B, C, D doesn't work. Try this one, doesn't work. Then you try A, it works. The next one is BC. Oh, wait, BC. It's BCC instead. BCC. BCC. So then do you add it into a set of things, not check again? No, that wouldn't work. Wait. If you check BCC, oh, you took the biggest one, and you know how many ways there are to create that string. BCC. Yeah. So by picking BCC, you count 2, because there's either taking BCC as a whole or constructing it with smaller strings. But the problem is when I backtrack, is there a chance that then, yeah, and then I'm gonna try for another way for this one, and then the next biggest is gonna be B, and then I failed. Fuck. Yeah, because what if you had C, C, D? In that case, it'd be correct to pick B, and then go for C, C, D. Man. And then if I pick B, then it might make me go pick C and C for the BCC. Oh man. And how do you make it black when you erase? Oh, what the fuck? Man, bring back the old paint. New paint is so trash. Oh, what? It erased it. Poggers, but it took forever. Oh. How do I save time? If I check RB, I want to avoid checking R and then B. How do I avoid that? Because if I put it for this if we're at this current, if I put for this substring, wait, no, so if we work by current, if this is the current one and we ban R, what if there's a BGB that it will never get to try once I do RB? Then I miss a count. Man, I don't know. So currently what I'm doing is I'm brute forcing all the ways to do it, so oops. Oh man, I hate the new paint. It's the eraser. Oh man, the eraser is white too? What's the secondary color even for then? The fuck? Oh, it's right click for secondary color. Oh man, but it doesn't make it a background color. There's layers. Oh wait, maybe that's the way. Maybe I gotta use layers. Okay, let's okay, let's add a layer. How do I change? Okay, I'm on this layer now. Okay, we're cooking. How do I make this layer on top now? Oh, it's ordering. Wow. Okay, now let's erase everything in this layer. Wait, Okay, okay. Yeah, I think this is the way. Okay, this is actually pretty good, pretty good. I think I might like the new paint. Okay. See, the old way we have R, B, G, B, R. And then I try all the possible ways. Let's say this. So we try R, we're able to get R, and then we try R, we're able to get R, we try B, we're able to get B, G, we're fine, B, we're fine, R, we're fine, we got one way, and then I backtrack, and then I try W, R, it doesn't work, and then I try B, doesn't work, B, W, U, doesn't work, R, B doesn't work, GB doesn't work, and BR doesn't work. So then I backtrack, and then I have BR, so then that's another way. And then I backtrack. Yeah, I tried them all, and I backtrack, and then I try. What? After G, it's what? PWU, RB, GB, BR, okay. So this is the part I'm trying to optimize. Yeah, so let's say we had R, B, G also added to the list, or just R, B. We also have R, B, G. So then we're gonna have R, B, and we know this one can be formed. Wait. This one is formed by R, B, or just R, B in one shot. And this one can be formed with R, B, G, R, B, G. Can also be formed with R, B, and G. And can also be formed with oh, okay, wait, I think I get it. R, B, and G. Wait, maybe I don't know. No, I don't think it'll work. And just RBG alone. So then I'm gonna read this one, and there's two ways of getting this. So there's two ways of getting this. So it kind of saves me from branching out if I know there's two ways. Oh, but what if once again there's another two ways? Let's say this one we have GBR. So I think it's a multiplication. Because if there's two ways to get this one, and then there's two ways to get another way, then there's four ways because two ways for each of them. So there's multiplication involved. Yeah, so we're doing this, and then we got G. Oh, we want to use the biggest one, so we have GB first. And then if we have GB, then we know GB can be made with just G, GB, or GB. So there's two ways for this one. And then this one, there's one way. So there's four ways of doing it with these. For this split, yeah, this way of splitting, there's four ways. Wait, so we're looking for all the possible ways to split it? No, because then if I split it smaller, then I'll be double counting. Wait, so how can I prevent the double counting? If I know there's two ways to split this. Wait, fuck. So I want to prevent exploring any subsets, any ways of splitting it this way. Is this a DP problem? It is. I think it's a DP problem in some way. Oh wait, I think I know how to do it actually. What if the way of doing this is you have R, R, B, G, B, R. If the first one is there, then we want the number of ways to get this one. And we store it into cache. Wait, does that work? Okay, so we found R. So then we just want the number of ways to get this one. No, fuck. So let's say we had, So this we know. Okay, well, okay to try. Okay, so how does a try work again? Oh man, I forgot. Let me look up a try. Oh, okay. Oh, okay. You build a try tree, and then you see if you can. You see the number of ways to explore it. Oh, wait a minute. The try tree. How does a try tree work again? Adam. Okay, so a try tree contains words. So I add all the words into the try. And then Wait. Wait, oh, I add them to the try. Ugh. But I'm only allowed to use wait, no. Okay, so let's try this. So I'm only allowed to use characters in this list. So BRWWR, so you got the null node first. So you have one way would be, and then another way is BR. And then from B, you have R, and you have RW. No, so you just have R, BR, and from BR you have WR, and you have W alone? No, so just WR. BRWR. And then from there, there's just R. Wait, let's try it with the RR whatever shenanigans. Oh wait, no, let's just finish building this tree first. Okay, you have WR. You got R, so BRWRR. BR. Do you have W? Yeah, WR. Wait, can you join trees like that? No, it only goes down, right? So yeah. Oh wait, but what if I traverse and I find it? Can I just copy the whole thing and transplant it there? Maybe that's the optimization. I don't know. BR and WR and R. I don't know, I'll watch a video and tries. I forgot how to use them.
Walk McDowell, author of Cracking the Coding Interview. Today I'm going to talk about tries. This isn't something CS students might have spent that much time on in school, but it's really, really important for interviews. A trie is a data structure that is actually a type of tree, but it's often used to store characters. And the way that it works is each node might store just a character as its data, but then if we look at the path from the root down to that node, that node is really representing a word or a part of a word. And so what it allows us to do is very quick lookups of a particular kind. So for example, suppose we use this trie to store this very small version of the English language. We could use it to say, hey, are there any words that start with CAR? Yes, there are. There's car, that's actually a complete word, but there's also card. So car is also a prefix. So it allows us to do very fast lookups. So let's talk briefly about the implementation of it. So we're going to need a class node, and then rather than having, as we would in a binary search tree, a pointer to the left and right node, instead we have some sort of either array of all the children, or more likely some sort of lookup table that maps from a character to that node. So we can immediately say, is there if represent node a complete word, or is it mapping of from character to node? Each node also has some sort of flag in it called something like is complete word that represents, is that a complete word or not? We see tries in a lot of problems. So if you're in an interview and you get a question that has some sort of word validation to it, so, check if this is, walk through this table and find all the, walk through this Scrabble board and find all the words. Or given this list of strings, find all the celebrity names. So when you see something that has some sort of word list validation, think about whether or not a try might be useful. Suppose you had a situation where a user was typing a word, and as soon as the word became clearly was going to be an invalid word, you want to say underline it. So someone types C, and you say, yes, that is in fact potentially going to be a valid word. And then someone types CA, okay, great, we're looking good. Now they type CAL, yes, okay, there's words that start with CAL. Now they type CALP, oops, no, that's an error. So that's a good case to use a try. Now the way that I've explained try is a valid prefix, yes there is, and then you do is CA a valid prefix, and you start from scratch over at the root. Now in a lot of cases though, we actually want these calls to kind of build on each other. So one thing we can do with our try is we can keep state in various ways. So when we look up is C a valid prefix, we actually store where we are in the tree. So when the user types the very next character in A, we just look immediately, is A a child rather of C, of that last lookup, rather than starting from scratch. And there's different ways you can actually implement that. One way you can do it is to actually keep state within the try. Another way you could do that is actually return the node back to the caller. So when I say is C a valid prefix, I get not only that it's a valid prefix, but I also get information that gives me exact reference to that node. Then, rather than starting from the root and saying is CA a valid prefix, I just ask, is A a child of C? And then I ask, is L a child of the CA? Et cetera, et cetera. So again, tries are not something that you would spend a lot of time in algorithms classes or...
Man, I didn't understand anything useful in that one. I forgot how... I don't know how to use it for this problem.
Here is an essential data structure for coding interviews. It's called a try, and they're used for storing words. Here is a try, and you'll see it's actually a tree, but it's a special tree where each of the nodes are letters. They're fast at storing words because all of the ones that start with D will be over here, all the P's will be here, and all the F's will be over here. If you want to master tries, I would do question 208 from Leetcode. Here is an essential data structure for...
BRWRR. So there's two ways of doing this one. How can I save time with that though? I know BR and here and BR are the same at the bottom here. I'll get ChatGPT. Huh. Insert all substrings into the try. Oh, wait. I don't get it. Given a list of substrings, strings count how many ways to combine them form another list of strings. For efficient substring lookup, okay. Oh, okay. The try is for these. Oh, whoops. So you have R. So when you want to start with the smallest ones first. Yeah, I think you sort them by length, right? Oh yeah, no. You can just do R, and this is a full one, and then you go W, and then R, and that's also a full one, and then you go B, and then you go G, and you go B, W, U, and this is a full one. I go R, B, and that's a full one. G, B, and that's a full one. And then B, R. Okay. And then how do I use the try? The number of ways ways to form the prefix of target. What the fuck? Okay, target to I. For each index I in target, traverse to the source string to check all possible matches. Let DPI represent the number of ways to form the prefix of the target list up to index I. The fuck? I'm basically cheating at this point. I can't do it. To form the prefix target source. Okay. For each index I in target, traverse to the source string to check all possible matches. One, two, apple, up. There's no A. Okay, dynamic programming for each target I in the target list. Use dp array dp target, where dp target j represents the number of ways to form the prefix of target I up to yeah, so it is DP. How do you DP this shit? At each step, try matching the prefixes of S. If a prefix match recursively, calculate the number of ways to form the remainder of S. Oh, wait. Oh, but I feel like there was a problem with that too. Wait, number of ways to form this one, number of ways to form that one, and then you try number of ways that one and that one. I feel like there's gonna be some overlap. And then, yeah, I was thinking about that, but why did I think it couldn't work is because you take like a small one, ways to form. Oh, wait. Yeah, I think it's because I wanted to multiply. Maybe that's the issue. Maybe I shouldn't think about that. What if I just took this, counted as 1? The ways to form S. Okay. I mean, I'll try it this way, see if it'll be fast enough. Oh, what the fuck? That was super fast. Oh man. Fuck. Maybe that's not right. What the fuck? Why is it printing nothing here? B, and then there's nothing left. What the fuck? Okay, I called it F. I don't know. Okay, there's nothing that goes into that. That's weird. Oh, I get 16 now. Maybe I copied it wrong. Okay, yeah, so I guess that was it. It wasn't too hard. I'm just not very good at this. Well, that was it. I'm not very smart. Sorry, guys. I ChatGPT'd it, but this is a pretty basic DP question. I'm just bad at DP. Lots of shame. I'll go to bed feeling very shameful for cheating, but it is what it is. Let's count it as practice for DP. All right, bye bye.